Hi, welcome to Rational Problem Solving. You'll notice that this says Unit 6. These are the same notes as last year, but since they haven't changed, I'm going to continue to use them for this year. The only thing that's not consistent is the page numbers. This is our old textbook. If you're interested in the new textbook page numbers, I will get those to you in class tomorrow. Okay, we're going to move into some word problems and some real-life examples here. We can use rational problem solving in a lot of different ways to help us solve real-life problems, and we're going to take a look at a few examples here. The first one is how we compare people working on a single job separately or people working together. So notice that Shelley can paint in 8 hours and Karen can do it in 4. We'd like to know how long it will take them to do the job if they work together. Very useful if you're trying to take care of people who are working on your house or anything like that, so you can hold them accountable to what they say they can do. So the time it takes both Shelley and Karen together to do one job is what we're looking for here. So if I do it as a ratio or a rate, she can do the one job in 8 hours. And likewise, Karen can do that same job in 4 hours. And we'd like to know how long it's going to take them total to do that one job together. Okay? So we're looking at a fraction of the time, because that's basically what's happening here. That one job is going to be divided into 8 hours. This single job is going to be divided into 4 hours for each person separately. However, together, we're going to add those fractions together, and that's going to give us our result. Just like we did before, we're going to look for our least common multiple here, or our least common denominator here, and that's going to be 8t. We're going to multiply that throughout the entire equation, and that gives us 8t over 8 plus 8t over 4 equals 8t over t. We're going to cancel out our denominators all the way through, and that's going to give us 3t equals 8 divided by 3, and the total amount of time it will take them to do the job together is 8/3 hours, or 2 2/3 hours. All right. We're going to look at this one, which is a similar problem to question number 1. Tim can stuff envelopes 3 times as fast as his daughter. So the amount of envelopes that Tim can stuff is going to be equal to 3 times the number that his daughter can stuff. Okay? So this one is going to be his daughter, and this one's going to be Tim. And this is how we're going to take a look at this particular problem. They can stuff 5,000 envelopes. If Tim does it, it's at a rate of X. If Georgia does it, it's at a rate of 3x. And we're wondering how many they have to stuff if they want to complete the job in 4 hours. Now we're going to simplify that number to 1250 first of all. And then we're going to look for our denominator, and that's going to be 3x. If we multiply that throughout, that's going to give us 15,000 plus 5,000 equals 3,750 times x. So we're going to get some more space over here. 20,000 equals 3,750x and x equals 5 1/3. Now, that's the amount of time that it will take Tim to do the job by himself. We want to know how much his daughter will take if she does it by herself, so we're going to multiply that number times 3. And that's going to give us 16. So this is going to be Tim doing the job by himself. This is going to be Georgia doing the job by herself. The next style of problem that you're going to run into are rate problems. That's these two problems that follow here. What I'd like to do to help us with this problem is I'd like to take a look at this distance rate time table that I've put together for us here. Okay? If we set these problems up in this manner, it makes them a lot easier to solve. All right? So we're going to go downhill and uphill. That's what we're going to fill into our table to help us understand which way we're going here. So what we're looking at here is we're looking at solving this problem for time. So if distance equals rate times time, that means that time equals distance divided by rate. And this is where our ratio is coming in, because each time we're looking for her rate, or looking for her time, or looking for her distance. So in this case, we've just got to fill in the parts that we know. She can jog 5 miles downhill, that's the distance. In the same time it takes her to jog 3 miles uphill, that's again distance. Notice we separate them inside the table. She jogs downhill at a rate 4 miles an hour faster than she jogs uphill. So that means that the downhill rate, even though we don't know what her speed is going to be x plus 4, because her uphill rate is just x. Now the reason we do that is because this one's faster. Downhill is faster than uphill. Now what we're going to do is we're going to combine these two together to create our third category, which would be time equals distance over rate. So this one will be 5 divided by x plus 4, and this one will be 3 divided by x. It says here that she can go downhill in the same time it takes her to jog uphill. So that means these two times are going to be equal. So here is how we determine what her speed is actually going to be. And now we're going to use that common denominator to multiply out our fractions, and that's going to be 1 of everything, which is on the bottom. That's going to be x times x plus 4. Once we distribute that through, this one cancels here, leaving us 5x. This one cancels here, leaving us 3 times x plus 4. Now what we'll do is we'll solve this out for x. 5x equals 3x plus 12. So we subtract 3 to both sides. That leaves us 2x equals 12, so x equals 6. Her speed is 6, in this case, miles per hour. So we're looking for her rate each way. So when she runs uphill, she's running at 6 miles per hour. When she's running downhill, she's running at 10 miles per hour. So uphill, 6 mph. Downhill, 10 mph. Always go back and double check that you've answered the question the way you're supposed to answer the question, so you know what you're looking for as you're going along. Okay? The next one we're going to do is we're going to take a look at this in terms of two different types of trains. So we're going to have a passenger train and we're going to have a freight train. And we're going to set up the same problem that we set up before. Okay? A passenger train travels 392 miles. So that's our distance. In the same time that it takes a freight train to travel 322 miles. If the passenger train travels faster than the freight train, that means we'll give the freight train the value of x. We'll give the passenger train the value of x plus 20. Now we can set up our time. That's going to be, remember, distance divided by rate. So that's 392 divided by x plus 20. And that's 322 divided by x. Now we bring those out here and we write our equation. The same time gives us the key to this problem. 392 divided by x plus 20 equals 322 divided by x. Again, we need our common denominator of x times x plus 20, and that's going to help us solve this problem as we distribute it through. This one will cancel, leaving 392 times x. In this one, the x will cancel, leaving us 322 times x plus 20. We'll distribute this through. 392 times x equals 322x plus 6,440. Subtract the 322 to both sides. Leaving me 70 equals 6,440. Divide both sides by 70, and that leaves me as x equals 92. It says find the speed of each train, so that means the freight train that's the speed, 92 miles per hour, and the speed of the passenger train is 20 more than that, which would be 112 miles per hour. So you see how the distance rate table helps us solve this problem very simply. You just have to fill in the parts properly in order to get the problems correct. If you want to take a look at this problem, I'd like you to practice using the distance rate table on your own. We will discuss this as a warm-up at the beginning of class tomorrow. So please, at the end of this video or now, whichever is more convenient for you, take the time to fill out your table and solve it. We'll move on to a third type of problem that we're going to see in these applications, and that's going to be predicting the amount of attempts or shots that we can do to raise our averages to a certain amount. This helps also if you're looking to get your grades up at the end of the year. You can actually use this to help you figure out what you have to make on future tests and quizzes in order to get your grade to where you need it to be. Alright, so the first thing we want to do is we want to look at what the basketball player has done right now. And what he's done is he has shot 58 out of 92. Okay? That puts him at about 63%. Okay? That's what he's doing right now. We want to know how many additional free throws that this person has to make in a row in order to raise the free throw percentage to 90%. Okay? So what we're going to do here is we're going to add attempts to the number of makes that she has. Well, for every time we add a make, we have obviously added a free throw to her total average. And that should be 82. I apologize for that. That will raise her average considerably, make it much more attainable. She's at 71% instead. Okay, so if we do this, now we can figure out what she needs to do in order to raise her free throw percentage to 90%. Well, that's going to be 90 over 100. So I'm going to go ahead and use that old standby of cross multiplication to help me out in this particular problem. I'm not going to bother doing my common denominator all the way through, although you could. All I need to do here is cross multiply. So that's going to give me 5,800 plus 100x equals 7,380 plus 90x. And then I just solve this out to figure out what my answer is going to be. Subtracting 90 to both sides, subtracting the 5,800 to both sides. It's going to give me what I need in order to solve this problem properly. So 10x equals 1,580, and I divide that by 10. So she has to make 158 additional free throws. Not very attainable for her, not very realistic, but that nonetheless is the answer that we would get. Using that exact same process, I would like you to practice question number 7 as well. Question number 7 is just like question number 6, so take a look at it and see if you can get this problem correct. We'll go over it again tomorrow as a warm-up in class. Alright, question number 8. What we're going to do here is we're going to look at renting out a bus and trying to divide equally amongst people who want to attend. That way everybody's paying the same amount, everybody is paying the right amount, and we're not overcharging or undercharging anybody on the trip. Okay? So we're planning a school field trip to a theater. It's going to cost you $60 just to rent the bus. Each theater ticket costs $5.50. So what we're going to do here is we're going to write an equation that helps us determine the number of costs per student. Okay? So each theater ticket costs the student $5.50 plus his amount or his part of the rental fee for the bus. Okay? So if I'm looking at that from my point of view, I'm going to go ahead and say my amount is going to be the $60 divided by the total number of students who sign up. So the more people I get to go on the trip, the better it's going to be for me. Plus the $5.50 that it's going to cost me just to get in the theater. Okay? So there is my equation I'm going to use. This is the key to this problem right here, setting up that ratio, knowing that I'm going to divide the total cost of the bus, but I also have to pay the full cost of the ticket. All right? And now I need to know what it's going to be if it's going to be $10 per student, and I'm just going to solve this problem using PEMDAS. So I subtract this through, and that's going to give me 450 equals 60 divided by x. I'm going to cross multiply on that to bring the x back up, and that's 450 times x equals 60. Now I'll divide out that 450 there, and that's going to give me my answer that I'm looking for. X equals 13 1/3. Now you have to go back and read what it says. We don't want it to be any more than $10. So if just 13 students sign up, I'm going to have a problem because it'll be a little bit more than $10 per student. So I really need that 14th student to sign up in order to get it below the $10 threshold. So 14 is the magic number, so I don't have to pay any more than $10. Okay? All right. I'm going to take a look at question number 9. Question number 9 is exactly like question number 8. It just is referring to a different style of problem. So you're going to want to take a look at that and figure out where your x value is going to go. And the hint I want to give you is average cost. And remember, average cost you always divide by the total amount that there is. Okay? So think about that when you're setting up your ratio and trying to solve this problem on your own. Additionally to question number 9, We'll do questions number 10, 11, and 12 at the beginning of class tomorrow as a warm-up. So please, at this time, if you have not gone back and worked through the questions I asked you to work through, please do that, because we're going to have a discussion, and then following that discussion we will complete 10, 11, and 12 to make sure that we're all on the same page and working these problems in the correct manner.